What? Yeah. Bye, Noah. I know. I'm leaving you.
By the time we're through today, you will have most of the answers to the packet. Anything that we don't do, you will do in groups, work together. All of the rules that we've been talking about are in the packets. If you haven't already written down write down what I write down. Go to the product with powers worksheet. All this is showing is in variable form what we've been talking about. If you multiply two variables with the same base, we end up adding the exponents. There's only really 5 rules. If you can memorize those 5 rules, then you can apply it to all the different types of problems that we see. There might be 50 different problems, but there's only 5 rules that you can apply. On each of these packets that you'll be getting from now until the end of the year, there's always examples that are given. What I found on the quizzes that you get back today, you guys weren't consistent. You do the correct method on one problem, and then the very next problem you would use a different rule. Be consistent. If you see multiplication, 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 you're using the same rule. You should have G9. You should have 2 to the 11th power. But if you don't have any variables, can't you figure out 2 to the 11th with your calculator? Do that right now. Do 2 to the 11th. 2048. So I did not take off on the quiz and didn't fully simplify it, but on the test I will. Make sure that if there aren't any variables involved, you're actually doing all the work. For number 5, what's a negative times a negative? Positive. For all of these, I am adding exponents. What if I don't see an exponent, like on this t? Put a little 1 there. So T3 and T1 becomes T4. There's nothing to combine with the R5, so it's just along for the ride. And if it helps, put dots in between to show that it's being multiplied. Until somebody tells me what X, T, and R are, I can't do anything with it. That's as far as I can go. 30. What should be on the C? 6, and on the D? 7. We're really just using one rule here. The mistakes we're seeing, people are doing the same thing to the coefficient. What should I be doing with the 6 and the 5? Multiply. It's a multiplication problem. The coefficients, you just do whatever you're doing. Multiplication, yes. No, because think of it this way. What does 2 to the 4th actually mean?
2 times 2 times 2.
And then you'd have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You'd be double multiplying if you did the 2 times the 2. Because it's just a number, not a variable, the 4 represents how much you're supposed to multiply. The 7 represents how much you're supposed to multiply. You'll notice here, these don't have any exponents on them. So if there wasn't anything on them, then we do the 2 times 2. You can do this anytime you're confused. It's called expanding the problem. If I don't remember a rule, write everything out like this. Negative 4 x times t times t times t. Then you can actually count up what you have in front of you. How many x's do we have? We have a total of 4 x's. How many t's? 1, 2, 3, 4. How many r's? We have 5. If it helps and you are forgetting something, expand it out. Write down every single letter that's involved. You'll still get the correct answer. It'll take you a little bit longer than just adding the exponents, but sometimes that helps. Next page. I call this power on top of a power. Now, is everybody aware that I'm interchanging the word power and exponent? It means the same thing. So I might say exponent on top of an exponent. What's happening to those exponents?
Multiply.
Multiply exponents. What I'm seeing on the quizzes, sometimes people are adding the exponents like we did with the previous problem. When they're on top of each other, we multiply them. What does that mean? What is 3 times 3 times 2? Do I have any variables here? So you should be able to figure that out with your calculator. What is 2 to the 18? A lot of numbers.
Got this. 26 to 1.
How do you say that?
262,000. Yeah.
262,144. Next rule. This is what I usually start with. I start with looking for an exponent on the outside. It's not a great mathematician's word. It's not a great mathematical word, but it helps you remember that if you see something on the outside of the parentheses, everything on the inside gets it. It's like distributing the power. The A got the M. The B got the M. I need earbuds put away. What does this look like for the problems? Everything. Everything gets that power of 3 because it's on the outside of the parentheses. Some of this you can take care of with the calculator. What is 5 to the third power?
5 to the third.
125.
Oh, that's what you meant.
What did we say with the previous rule happens when you have powers on top of powers?
Multiply. So x
6, y,
3.
3, z,
I thought that was a 2.
12. Powers on top of powers, we multiply. I can't do anything else with that, I'm done. Until somebody gives me more variable information, I can substitute. Yes.
So if we're saying that if b equals 2, would you do the same thing and then just simplify that into what its real number is?
Into what?
So like if you have like a 2 where the z is, you 4 times 3 first and then simplify that.
Then you do 2 to the 12, yeah.
Realistically speaking, what's going to happen?
After a while, you don't need to show me this step. For the quizzes, I want to see all the steps. But couldn't you do 3 squared in your head?
Yes.
Couldn't you do 1 times 2 in your head?
Yeah.
Couldn't you do 4 times 2 in your head? After a while, you won't need to show me every single step.
Wait, 3 times 3 is not minus 27. Oh no, never mind. Wait. I thought you said 3 to the third. That's what I heard. I heard 3 to the cube. I think you're square.
3 to the second.
That's what I said.
Putting it all together. Don't do everything at once. You're going to see maybe one problem like this on your test. So what I would do is do this first. Deal with it in chunks. What happens to that 2 if it's on the outside? Everything gets the power.
2.
So I've got 9x squared y 8. But that's only half of the problem. I've got parentheses and brackets. There's no difference between parentheses and brackets. They're the same thing. Some textbooks wouldn't even put in brackets. They just put another set of parentheses. So it's no difference. Deal with this first. I'm not even going to look at the 3 unless you want to take care of it right now. What do we do with powers on top of powers? So this is really negative 2y to the
third. I mean 6.
6. But is that 6 still on the outside of a bunch of things? So everything inside gets the 6. If you do this on your calculator, make sure you do parentheses because it's a negative. Everybody right now put parentheses, negative 2, parentheses 6, and tell me what you get. Did you put it in parentheses? You should get a positive something. Are we done?
No.
Now I've got to put the 2 parts together. What's 9 times 64? What should be the exponent on the y? 14. It's not a power on top of a power. It goes back to our first rule, adding the exponents. We're not going to be doing all the questions together. I'm going to leave number 2 for you to do when you get into your groups. Next page. This is new. Because that's where you stopped after your last group session, or we're supposed to stop.
Yeah. It was. Wait, why? I don't like
Anything else? This is our easiest rule. If you see a power of 0, it does not mean 0. What does it mean? It means 1. I need everybody looking this way. Noah, this is my time. At 9 o'clock, when you move into your groups, you'll have all day long to talk to each other. This is calculus. You're actually doing low-level calculus in this class because that's why a to the 0 equals 1. If you look at 2 to the 3rd power, what is that equal to? What's 2 times 2 times 2? 8. What is 2 squared equal to?
4.
4. What is 2 to the 1st equal to?
2.
Just 2. Do you notice that these numbers are getting smaller? In calculus class, you would look at a graph, and it would get smaller and smaller and smaller, and would get closer and closer to 2 to the 0 being 1. It's really a rule that's based on a graph. You follow the graph, and when you get to a power of 0, the graph tells you that the answer is 1. That's the only real reason why we do this. If you get to a calculus class, you'll then take information like this and use it in a variety of ways. We're just using this one rule from calculus to help us out this year. Anything to the 0 power is equal to 1. After SOLs, if we get a chance, we'll actually take a look at the graph and see why this actually is 1. Because what would you figure something to the 0 power would be? 0? But it's not. It's equal to 1 because of the graph. What does that mean? That means that if I have 15 to the 0, what's the answer?
1.
If I have a whole bunch of stuff,
1.
it doesn't matter how complicated it is, if the outside exponent is 0, that's equal to 1. But chances are you're not going to see something like this. You'll see something where part of the question is to the 0 power.
Okay.
What's a to the 0?
1.
But what's 2 squared?
4.
So this one is 1/4.
Oh, no.
So sometimes the entire problem might be 1, sometimes a piece of it is 1. Look for the power of 0. Negative exponents. I want you to cross out the word negative, but leave it, don't totally cover it. Negative exponents does not mean negative. Did everybody hear that?
Negative exponents do not mean negative.
Means reciprocal. Do you know what a reciprocal is? Write down the word that he just said. Look. So when you see a negative exponent, it's not telling you that you have a negative number. It's telling you move this to the other side of the fraction, which really flips it. So we're showing variables here, but I'll show you an example. If I see 5 to the negative 2, it's not negative. What it really is telling you is to move it to the bottom of a fraction. So put this over 1. We can make anything into a fraction by putting it over 1. Now flip it.
So it'd be 1, 5 then.
Nope. Once you flip it, you no longer need the negative. The negative is just telling you this really should be on the bottom. Mathematicians sometimes use the negatives, but they like positive exponents better, so it's better to show it like this. That's what this is actually saying. That anytime you have a negative exponent and it's on the top, move it to the bottom. move to the bottom.
So then the answer would be 5, 2.
It'd be 1 over 5/2, so 1 to the 25th, but we can leave it like that for now. Well, what if you have it and it's already on the bottom? What if I have something like 1 over 6 to the negative 3? It's telling you it's in the wrong spot. It should be moved. Since it's on the bottom, the only place you can move it to is the top. This actually means this. When you move it, you no longer need the negative exponent. So did we end up with any negative numbers here? No. It just tells you move. In this case, we're moving to the top. That's it for exponent rules. If you use the rules correctly, you can do them in almost any order that you want. Everybody's problems are going to look different on these quizzes and tests. The answer will look the same, but the process to get there might look different.
Why doesn't the exponent stay negative?
Because this is just a designation that means I'm a reciprocal. This is saying I'm a 6 and I'm not really negative 3. I'm really 6 to the 3rd, but I should be on the top. I'll show you what that means with these problems. In order to save space in textbooks and when mathematicians and scientists are doing research, they'll use negative exponents. But we want to look at it as a fraction. A negative exponent is telling you, move me. This is saying, I'm an x, move me down. Once you move that exponent, it no longer needs to be negative.
So, back to the last line. When you flip it from top to bottom, whatever you did, it was negative before. Every time you flip it, it becomes positive.
Right, because the negative exponent really doesn't do anything to the value. It's just telling you, I should be in this other spot. Does the y have a negative exponent? It stays where it is. It's good right where it's at. And if you want to put the original over 1, just to help you see where the numerator and denominator are, go ahead and do that. This is done. This is what we want. We want something without the negative exponent. So tell me what I should move and what should stay in number 2.
And negative 5 should go down.
Once you move it, you've taken care of the position and now you don't need the negative.
R negative 2 should move up.
R negative 2 moves to the top, this moves to the bottom,
And P stays there.
and P stays at the top. So it's not really changing the value at all, it's just telling you move me. But don't forget your rules for everything else. If you had just 4 over negative 20, could you reduce that? So reduce it. What's 4 over negative 20? 1/5. That rule doesn't change. Now start moving things around. Where should the x go?
Underneath.
Underneath. Where should the y go?
Stay up there.
Stays up there. Where should the z go? Up top. Oops. Once I move it, I don't need the negative exponent. And that's the mistake you'll make. I make that mistake all the time. But I double check myself. That's as much as I can do right now. You'll notice, are there any z's on the bottom here?
No.
Are there any
Yeah.
y's?
Oh, no.
The next set of questions, you're going to have x's and y's and variables on top and bottom. What's happening when we have division? If I've got division, I end up subtracting exponents. I'll show you the short and easy way, then I'll show you if you forget all the rules. Stay with us, Brandon. Is Ethan alive?
Yeah.
Okay. Because if he's not, then I have to fill out a lot of paperwork. If there's no exponents, what do I put in there? Put a little 1 right there. Put a little 1, little 1, little 1. What is the rule I just told you you do if you have division? You subtract. Always go top to bottom. Always make a fraction box. What is 3 minus 1? Your answer always goes on the top. What is 2 minus 5? It always goes on the top to start with. Put a 1 on the bottom. But mathematicians don't like negative exponents. So what should I do to the negative exponent? Does the G2 stay on the top?
Yeah.
If the H3 moves to the bottom.
So if you have, you know how you have that 1 underneath? Would you put that 1 underneath when you did that?
We did. I'll show you why we did what we did right now. If you don't like looking at the subtraction and doing it that way, you can expand your problem. Point over to here. Let's say you forget everything, you lose your mind. You can expand it and just write down exactly what's in front of you. How many G's are on the top? 1, 2, 3. How many H's are on the top?
2.
How many G's are on the bottom?
1.
How many H's on the bottom?
5.
1, 2, 3, 4, 5. This is why subtraction works, because subtraction is really cross-canceling. What can I cancel out in the G's? How many G's?
1.
Cross it out. How many G's are left on the top? That's what we got on the top. How many H's can I cancel? 1, 2. How many H's are left?
30.
So you can do it this way. This is harder when the exponents get a lot bigger. Or you can just think to yourself, I'm subtracting exponents, and then I move any negatives to the opposite end. If it's on the top, I move to the bottom. If it's on the bottom, I move to the top. It makes sense. Are there more H's on the bottom? So there should be H's left over on the bottom after we cancel. Look at number 2. How many, let's use this method for number 2. Where are there more X's, on the top or the bottom? Bottom. How many more are on the bottom? So all of the X's cancel except for 1 on the bottom. Where are there more Y's? How many more?
3.
You could look at it this way. I'll do this one down here. We had X, X, Y, 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 Y. 3 X's, and then a Y. You can cancel out this one and this one. You can cancel out this Y and this Y. How many Y's left?
3.
3. How many X's left? Just 1.
Oh.
So you can use the subtraction rule, or if the numbers are small enough, you could spread it out and cancel out and see what's left. For something like this, I would use the subtraction method. These are a lot bigger exponents. What do I do with this? Just reduce it. What is 3/9 reduced? 1, 3. So that became that. Let's use the subtraction method. What is 7 minus 5? Answer goes on the top. What is 10 minus 3?
7.
7. What's 1 minus 1?
1.
0. But what did we say all 0 exponents get you? So do I really need these? No, they cancel out. You're done. You have k squared m7 over 3. You don't really need the 1. And it makes sense. How many more k's do you have on the top? 2. How many more m's do you have on the top? 7. Next page. Yes. You've got some choices. You don't have to do, all of you don't have to do the same thing at the same time. How would you start number 4? What would you deal with first?
Numbers.
If I was doing it, I would take care of the coefficients first. What is that reduced? Negative 1/4. It's considered good form to push the negative either to the side or the top. Do we have a bunch of negative exponents here? Well, how about if we move them first? I could do it at the end, or I could do it now. I prefer to move around the negative exponents first, and then see what I've got. So would I move R3? Yes, it's negative, so I'm moving the R3 to the bottom. Do I move the T4?
No.
Keep that there. R2 is positive, I just keep it there. T7 is positive, I just keep it there. What about the U negative 5? Move that to the top. This would get you half credit. You've gotten rid of your negative exponents. Do you have any variables that are the same? What is R3 times R2? Right here. R5. It's still on the bottom. Is it a power on top of a power, or is it just 2 powers next to each other? If it's next to each other, it's just 3 R's and then 2 more R's, which is 5 R's. You only multiply it if it's a power on top of a power. What you're thinking of, Kat, what you're thinking of would be if you had that. You don't have that. How about is there anything to combine with the U5? I got T4 and T7. I could subtract it, or I could think to myself, where are there more T's?
Where are there more T's?
How many more?
3.
If I subtracted, what is 4 minus 7? Negative 3. So I would have had T negative 3, but then I would have had to move it to the bottom anyways. There's many ways to get at your answers. Somebody raise their hand. Tell me what you would do first if you were doing number 5. There's no wrong answer unless you give me the wrong rule. Okay. What do you want to do with it? She's going to take this and she's going to move it to the bottom. She can do that. That's a good rule. So we took care of that. What next? What else do we want to do? Sure.
Eliminate the W's.
Can we eliminate the W's? Yeah. We got W over W. That's equal to 1. That's gone. How about the X2? Should I do anything with that? Let's leave it up there. What about Y negative 6? Where does it go?
Top.
Now I take a look for stuff that's the same on the top and bottom. Are there any other X's? Any other Y's?
No.
Any other V's?
No.
I'm done. Can't do anything more. And that's how it should look at the end. You should have all positive exponents. You've taken care of any negatives that have shown up. I'm looking at 32 and 4, and I'm thinking that that's 8. I could put 8 over 1 if I wanted to. I don't really need it. Raise your hand. Tell me how you want to deal with this. Give me one way of looking at it and dealing with all of these variables.
Start by flipping the negatives.
Let's flip the negatives. I'm going to move A8 to the bottom, but what A is already there? A3. I've got B3 up here, B5. Those are all positive. Where should the C4 go?
On the bottom.
Bottom. And the C2? On the top. Yes. Where are all the A's?
On the bottom.
On the bottom. So they're going to stay there.
Wait.
How many A's do we have? A 11. I got 8 A's, then I got 3 more A's, now I got 11 of them. What do I do when I have variables on the top and bottom?
Cross them out as much as you can.
You can either cancel them out as much as you can, or you could subtract. I'm going to show both. What is 3 minus 5?
-2.
Your answer always goes on the top if you subtract. What's 2 minus 4? -2. But, what are you supposed to do with negative exponents?
Flip on.
Move them down. So this would go down here, and this would go down here. So I could end up with that as my answer.
8 over nothing.
Or I could think about it the way you guys just told me, that I could cancel things out. Here's another way of looking at the same exact problem. If I see this, that means 8 followed by 3 B's and how many C's?
That's 2.
2. On the bottom, how many A's do I have?
11.
How many B's?
3. 2.
2. How many C's?
That's 2.
2. Nope. I'm sorry.
Oh, no, that's
Up
two
here.
over
Up here we're
five.
talking about.
4.
So we got 5 B's, 1, 2, 3, 4, 5, and 4 C's. So I took this and I made it look like that. What can I cancel?
Everything.
Can I cancel any A's? No, so I have A11. How many of the B's can I cancel?
3.
1, 2, 3. How many B's are left?
2.
2 on the bottom. How many C's can I cancel? 1, 2. How many C's left? So you could either spread everything out and cancel it this way, or you could do subtraction and get the same answer. Either way, we end up with this as our final answer. The more you do this, the easier this gets. There's lots of ways to get at the right answer. Last rule. This is really just a variation on having a power on the outside. What happens when it's on the outside?
Multiply everything on the inside.
Everything gets it. And this is just saying it doesn't matter if you have a fraction on the inside. Everything gets the power. So if I have 5 squared over 6, and this is all to the 4th, let me put an A in here also. If I have something like that, that's a fraction. It doesn't matter if it's a fraction, everything gets that power. So the 5 squared gets the 4. The A gets the 4. The 6 gets the 4. What do you do with a power on top of a power? That's 5 to the 8, 6 to the 4. Can you do 5 to the 8 on your calculator? If you can do the problem with the numbers that are in front of you, simplify. This is 390,625, A4. Then I've got 6 to the 4th underneath. That's 1296. Let me see if this reduces. 1296. Nope, that's as simplified as you can make it. So it's really the same rule, but now we're applying it to fractions also.
Stop.
Last problem I'm going to do with you is the first example on this page. Exponent on the outside. Everything gets it. Everything gets that outside power. Simplify for me. What's 3 squared? 9. How about p to the 3 to the 2?
That's P6.
How about 7 squared?
7 squared. I mean 14. 49. Oh, 7 times 7.
I need you to go back. If there's any problems in this entire packet that you have not done, you're going to do them. There's a few more at the end that I have not done. While you're working in your groups, I'm going to call you to my desk and give you your quiz back. And you can start corrections on that.
Can I pass this out?
Please.
I'll give you a call.
Do you have other packets in your...
Yes.
I need you to finish up whatever's not completed on the scientific notation packet. And there's a multiplying polynomials packet. You have 3 big packets. That's what you should be doing right now. Finishing packets. Yes. Can you change the light for me? Thank you.